Okay, we're going to go to math.com, click on the algebra. Let's go down to linear equations, and this is going to be 1.2. So we defined what a linear equation is, what it looks like in standard form in the previous problem, and worked a fairly simple example. Now, I'm not going to go through and actually check to see, once we get the solution, check to see if that is the solution or not, because you always want to, once you get the solution, you want to go ahead and plug it into the original equation to test to see if that's actually a solution. Okay, because you may have worked the problem out incorrectly, or you may have worked the problem correctly, but it turns out that that solution is not a solution, and we'll get to that. We'll get to some of those problems here in just a little bit. Alright, so I'm not going to go through and actually plug the number in. You can go ahead and do that. You'll just have to take my word for it that this is a solution. Okay, so here we are. We've got this equation, and we want to solve for x. And so what I'm going to have to do here, it looks like, is I'm going to distribute the 7 across. So we have 3x plus 7x minus 14, and that's equal to 20. And of course we want to collect up our like terms, and so we have a 3x and a 7x. That's going to give us 10x minus 14 is equal to 20. And then we take the 14 over. Alright. And then of course we have 10x is equal to 34. Is that right? 34. Multiplying 1/10 to both sides to get this to become a 1, we end up with 34 over 10, right? Let's take that, or think of just taking it diagonally down. That's the way I do it. Alright, now of course we'll want to reduce this down as small as possible, and we get 17 over 5. Okay, so 17/5 will be a solution to this equation. Alright, well let's work another one here. Over here at gotomath.com. So we have 5z minus 7z. I think our 7 tried to morph into a z actually. Right, 7z minus 4, and that's going to be minus 2 is equal to 5 minus 3z plus 2. Alright, so let's go ahead and let's see, we'll rewrite 5z here. Distribute this minus across, so we got minus 7z, and minus and a minus is plus 4, minus 2 is equal to 5 minus 3z minus, that's a 2, right? Yeah. Obviously it's not a z. Alright, now let's collect up our like terms. We've got 5z minus 7z, so that's going to be minus 2z. And that was a 2, yeah. 4 minus 2, that'll be plus 2. Right. And what do we got going on over here? We got 5 minus 2, so that's going to be 3 minus 3z. 3 minus 3z. Is that right? Yeah, 3 minus 3z. Okay. I don't know. Alright, let's take the 3z over to the left. So we're going to have negative 2z. I need to make my 2's not look like z's. Plus 3z. And then we'll take that 2 over to the right. 3 minus 2. And so we end up with z is equal to 1. Z is equal to 1. Okay. Alright, so that's going to be, and you could say that the solution set is the set that contains 1 for this equation here. Alright. So, if you're writing an application, it's extremely useful to have this skill on how to actually construct linear equations and then, of course, solve for a particular variable. It's very powerful stuff. Alright. Okay, so we're over here at, we'll work some application problems in the next section. We're over here at gotomath.com, working some algebra. We're looking at linear equations, and I'll see you in the next problem.